Okay, now let me summarize what we have learned. So, when do we use the greatest common factor to factor a polynomial? If we found that every term in the polynomial has a greatest common factor, then we will use this method. So, for example, you see, in this polynomial, every term has a common factor, which is 4x. So, to factor this polynomial, we can factor out this greatest common factor, 4x. And then, in the second factor, first, there are going to be 4 terms. Now, how do we know there are 4 terms? Because in the original polynomial, there are 4 terms. And to decide each term, we use the original term to divide by the greatest common factor, 4x. So, therefore, 12x to the third divided by 4x, we have a 3x squared. So the first term is 3x squared, and plus 16x squared divided by 4x. So it's 4x. So plus 4x. And the 4x divided by 4x equals 1. So the third term is 1. And 8x to the fifth divided by 4x. So that is 2x to the fourth. So the last term is 2x to the fourth. And when do we use factoring by grouping? Now, if we have 4 terms, if the polynomial has 4 terms, and not every term has a common factor, then we can use this technique to factor this polynomial. So I put the first 2 terms in one group, and then I put the second 2 terms into one group. And in each group, we found their greatest common factor. So between 6x squared and 2x, the greatest common factor is 2x. So therefore, I factor out 2x. And then 6x squared divided by 2x is 3x. So we have 3x. And the 2x divided by 2x is 1. Okay. And between 15x and 5, the greatest common factor is 5. So factor out 5. And 15x divided by 5 is 3x. And 5 divided by 5 is 1. And now, remember, after we factor out the greatest common factor, we should have the same binomial. And if you find that you don't have the same binomial, that means you must do something wrong. So you want to go back to check your previous steps. So now, since I have the same binomial, therefore I factored out. And I have a 2x plus 5. Okay, and also we said if in the second group, if it has both positive and negative greatest common factor, we will factor out the negative greatest common factor. Okay, and the third technique we have introduced is difference of 2 squares. And when do we use this technique? If we have a perfect square number times a square of variable minus another perfect square number, or minus another perfect square number times square of another variable, then we can use this technique to factor this binomial. So for example, here I have 25x squared minus 49 or minus 49y squared. So first we write 25 into 5 squared times x squared, and we write 49 into 7 squared, write y squared. So this becomes 5x squared minus 7y squared. And then this is 5x plus 7x times 5x minus 7x. So the formula we're using is from the special product of binomial. So a squared minus b squared is equal to a plus b times a minus b. And we said also, if you find the coefficient is not a perfect square, it's not perfect square number, then you may want to check if there is a greatest common factor we can factor out. And then we see if after we factor out the greatest common factor, can we use the difference of two squares? Can we use the formula of difference of two squares? So let's say we have 27x squared minus 12. Okay. Now, as you can see, both 27 and 12, they are not perfect square number, so therefore we cannot use this formula directly. However, since 27 and 12, they have a common factor 3. So let's see what will happen if we factor out 3. Now, after I factor out 3, it becomes 3 times 9x squared minus 4. Now, both 9 and 4 are perfect square number. So we can write this into 3 times 3x squared minus 2 squared. So we can use the difference of two squares formula to factor out this binomial. And it will be 3x plus 2 times 3x minus 2.